Welcome back to College Algebra videos. Today we'll be solving exponential equations. In fact, we're going to be using a certain property of exponential equations. And if you remember, there's this one that says that if you have a base and you have a power and you raise that to another power, then you're allowed to multiply both of those. So you get a to the mn. This is the main rule that we'll use for most of the equations today, so keep this in mind. And then the other thing that's going to be helpful is knowing certain powers of certain numbers. So, for example, to know that 2 cubed is equal to 8, or to know that 3 squared is equal to 9. These things will be very useful today. So it's important that we know our exponent rules to be able to do today's assignment. Okay, let's start with an example. In fact, that's all we're going to do is examples in this video. Let's solve each exponential equation, and we'll check our answers by substituting into the original equation. So here is the key to most of these problems. You look at the number on the left, which is a 3, and you look at the number on the right, which is an 81, and you wonder, is there a base that relates both of them? Can I write both of them to the same base and a power? Well, if you remember, 81 is really 3 to the 4th. And so if you know that, then now what you can do is you can say the following. So this is the way we would write it. We would say, so this is sort of what happens in my brain here. And so I say, oh, so I got 3x plus 2 is equal to 3 to the 4th. But now we have the same base, and we're raising to the power. And so one way to think about this is that the exponential function is a one-to-one function. That's why we can find an inverse. So because of that, that's sort of the official reason, but because of that, we can say, oh, let's just let the powers be equal to each other. X plus 2 is equal to 4. And so this means that x must be equal to 2. So that's what our solution would be. But remember, that directions say check your answer. So let's go ahead and check. So let me do the check in red right here on the left. So here's my check. And so what I need to do is plug in the 2. And so I go 3. So let me write that in blue. And let me replace the x with 2. Is it true that 3 to the 2 plus 2 is 81? Well, 3 to the 2 plus 2 is 3 to the 4th. And is it true that this is 81? Well, of course it's true. So we'll go ahead and check that off. And so this is the correct way of doing this. All right, so let's try a few more. We go to this next one. Now, this is a little bit tougher, because now, when you look at 32, it's not really a power of 8. In fact, let me kind of think a little bit here on the side. I know that 8 to the 1st is 8. I know 8 to the 2nd is 64, but I'm not getting 32. And so there is another way to think about this. There is another way to sort of analyze this. And the fact is that we need to find a way to relate 2 and 32 to the same power. And the way I can do this is as follows. I notice that, again, my thinking. I know that 2 to the 1st is 2. I know that 2 squared is 4. I know that 2 cubed is 8. Ooh, that's promising. 2 to the 4th is 16. And 2 to the 5th is 32. Oops, excuse me. Let me erase that really quickly. 2 to the 5th is 32. And so notice that here we have two very nice candidates. I can relate 32 and 8 by a power of 2. So the way I would rewrite this, I would say, oh, well, 8 is really 2 cubed, but it's being raised to the x plus 2. And 32 is really 2 to the 5th. But now I can use that rule I told you guys earlier about I have that if I have a to the m raised to another power n, I just have to multiply a times n to the n. So here, the way you're supposed to do this correctly, it's 3 times x plus 2. And we need to put the x plus 2 in parentheses. Otherwise, it doesn't make sense. We need to multiply the 3 with this whole expression. And so what we get when we distribute the 3 is we get 2 to the 3x plus 6 is equal to 2 to the 5th. And now that it looks in this form, we can go ahead and set the exponents equal to each other. It's okay now to take this and set it equal to the 5. And so we get 3x plus 6 is equal to 5. We subtract 6 from both sides. So we get that 3x is equal to negative 1. Let me scroll down a little bit. And so we get that x is equal to negative 1/3. Alright, so how does this work? Well, now we'd have to check, right? So I'd have to say, okay, what's 8 to the negative 1/3 plus 2? Well, this is really 8 to the negative 1/3. And I got to put this over 3. Okay, this is my check here, by the way, in case you're wondering what I'm doing. And if I put 2 over 1, I have to multiply by 3, so it's 6. And so I get 8 to the 5/3. Well, fortunately, you've already watched the video on fractional exponents, and so you know that this means that what I need to do is take the cube root of 8 rational exponents, and this is to the 5th power. The cube root of 8, you know, is 2, and because of my thinking earlier, we know that 2 to the 5th is 32. And so it does check out. And so you see, the video before where we talked about rational exponents is important, because I do want you to know what it means to raise something to the 5/3. All right. I suggest that you try this next example. Pause the video right now, try it yourself, and then come back and see what the answer is. Okay, so if you're back, we need to relate both the 32 and the 16. And so hopefully you remember the work from the previous slide. Hopefully you maybe rewinded, but if not, I want you to recall that 2 to the 1st is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32. And so now that I have this, I can see, here we go. This looks promising. I can replace 32 with 2 to the 5th, and I can replace 16 with 2 to the 4th. And so what I get, the way I'm supposed to write this is 2 to the 5th, which is 32, raised to the x, equals 2 to the 4th, which is 16, raised to the x plus 1. Now I need to multiply the powers, so here I need to multiply 5 and x, and then over here I need to multiply 4 and x plus 1. And so the correct way to write this is 2 to the 5x is equal to 2 to the 4x plus 1 with the parentheses. Well, now since they're both since the base is 2 on both of these, then I get 5x equals 4x, 4 parentheses x plus 1, distribute, so I get 4x plus 4, subtract 4x from both sides, and I get that x equals 4. All right, let's go ahead and check. I'll check here on the left. Check. 32 to the 4th power is supposed to be equal to 16 to the 4 plus 1. Now this might require a calculator, just to make sure that we get this correctly. And so when you punch this in your calculator, you should get that they're the same. So I'll let you check on that, because that's just a calculator problem, and you can do that at home. And it is correct, by the way. All right, final example. This is one of the tougher ones. And so here, I need you to remember negative exponents. So we know that 3 squared is equal to 9. We know that 3 to the 1st is equal to 3. You know that 3 to the 0 is 1. But you've also learned that 3 to the negative 1 just means take the reciprocal and then raise it to that power. Well, that's just 1/3. So hopefully this reminds you, this is why I asked you to graph so many 3 powers. 3 to the negative 2 is really 1 over 3 squared, the reciprocal, and this is just 1/9. And so here's a way I can relate. I know I can replace 1/9 by 3 to the negative 2. So when I try this, I say 3 to the negative 2 to the x minus 5 is equal to 3 to the 3x. Here on the left, I need to distribute. I need to put x minus 5 in parentheses and then distribute this. So I get 3 to the negative 2 times x minus 5 is equal to 3 to the 3x. Now we can set them equal to each other. So negative 2 times x minus 5 is equal to the 3x. So I get that negative 2x plus 10 is equal to 3x. Add 2x on both sides. And so now, let me scroll down here, we get that this cancels, 10 equals 5x, and so when you divide both sides by 5, you get that x is equal to 2. And again, we can check this quite easily. 1/9 to the 2 minus 5 is equal to 3 to the 3 times 2. 1/9 to the negative 3 is equal to 3 to the 6th. No, 1/9, sorry, 1/9. Well, this means the reciprocal, so take 9 to the cubed n is equal to 3 to the 6. And again, this is something you can check on your calculator, and it is definitely true that these are equal. All right, I hope this helps. The next video will be on something different, so have fun.